Good morning, students. Welcome back to JCE Connect e-learning platform, and we will be dealing with the fifth module. In the fifth module, we have in the previous videos we discussed about the phase lock loop. What exactly phase lock loop is? Block diagram representation of phase lock loop. How the phase lock loop will be operating, and other thing. Okay, and also we started with in the fifth module. In the previous video, we started with the timer IC, that is 555 timer, IC 555 timer. Internal architecture of IC 555 timer, and what are the different pin description, what are the different pins which we are used in the IC 555 timer, and what are the functions of the each pin in case of the IC 555 timer, and other things we discussed in the previous video. Okay, in this video we'll discuss about uh, modes of operation of IC 555 timer. So these IC 555 timers is operate in three different modes. So first one is your monostable multivibrator. It can be operated as a monostable multivibrator, that means only one stable state, and it can also be operated as a stable multivibrator. Okay, there is no stable state, as the name itself, bistable state, that is two stable states in case of the multivibrators. So before this, what exactly multivibrator is? Okay, multivibrator is a square wave oscillator. Okay, it is a oscillator, you know, oscillator is a circuit which produces the continuous oscillations. Okay, if the circuit is producing the square pulses, okay, that is called as multivibrator. Okay, multivibrator is a electronic circuit which is used to produce the oscillator, which is used to produce the square wave oscillations. Okay, that is called as your multivibrators. So in that multivibrator, your 555 timer can be operates in three modes. One is monostable multivibrator, and it can be operated as a stable multivibrator, and third is it can be operated as a bistable multivibrator. Okay, this is the operations of your multivibrators. So let me discuss one by one about the oscillators. So first is 555 timer as a monostable multivibrators. You can see the pin description of your 555 timer. You already discussed how the pin configuration is in case of 555 timer. So in this case, so to have your 555 timer to operate as a monostable multivibrators, so we have to connect the circuit in this particular fashions. So how it is connected? You have a IC 555 timer, so you have to first you have to understand what exactly the IC 555 timer internally consisting of. In the previous video we discussed what exactly the internal structure, internal architecture of IC 555 timer. So what it consists? It consisting of a voltage divider network, comparator, and flip-flop, and then one converter. Okay, these are the three main important components of IC 555 timer. So this your IC 555 timer consisting of all these three components. What is that? One is voltage divider network, two is comparators, and three is flip-flop. Okay, these are the main components of IC 555 timer. So to work this IC 555 timer as a monostable multivibrator or as an unstable multivibrator, there should be some external connections we have to have. Okay, so that is we are explaining here. What is the external connections to work this IC 555 timer as a monostable or unstable multivibrator? We'll discuss now. So first is, so your VCC, as I said, it can be varies from plus 5 to 15 volts. So the voltage range is plus 5 volts to 15 volts. So the supply VCC pin number 4 and pin number 8. So pin number 4 and pin number 8 are short circuited, and it is connected to the supply voltage. So supply voltage VCC, that is two pins are connected. So once again, so pin number 5 is connected to ground through the capacitance. So one capacitance is used, so pin number 5 is connected to ground through that particular capacitor, and similarly pin number 1 is also connected to ground. Okay, these are the configurations, right? So these and the pin number 3 is the output pin, so from where we can get the output of the circuit. Okay, this is the pin configuration. And extra connection what we are making in case of stable or in case of monostable multivibrator is this is your extra thing. So that is a resistance, one resistance and one capacitance, is a extra thing which we are connecting. So it is connected to pin number 4. One resistance is connected to pin number 4, and it is also grounded through the capacitance that is also grounded. And pin number 2 is for the triggering input. To give the trigger input, pin number 2 is used here. Okay, and pin number 7 and 6 are also connected to threshold point. You can connect the even multiple number of resistance also here. So one resistance connected here, two resistance are also connected in some of the cases. Okay, that is in case of the stable multivibrators. We have a two resistance. Here is a monostable, only one stable state, so that is why it is called as only one resistance is connected. So what exactly, we'll discuss it. Monostable multivibrator. Mono means you can see only one state, one of the output will be stable and the other is a quasi stable state, that is not stable. So that is why it is called as. So if you observe the output of this multivibrator, or its multivibrator is nothing but it's a square wave oscillator. The oscillator which produces the square pulses are called as a multivibrators or square wave oscillators. So why it is called as a monostable multivibrator? The output of this will be only one cycle will be stable and other cycle will be unstable or quasi stable. So that is why it is called as a monostable multivibrator. Okay, so if it is two states are stable, that is called as a bistable multivibrators. If none of the states of the output is stable, it is a unstable waveforms if you are getting at the output side, so that is called as a stable multivibrator. Okay, this is the description of a stable and monostable multivibrator circuit. So it is equivalent circuit diagram of your monostable multivibrator, and description I am just given here. You can just refer here description. So here in the standby state, that means in the initial state or in the off state, so you have a flip-flop that holds the transistor Q1 on. So transistor where it is, you just recall the timer diagram. So timer, it consisting of a transistor also. Okay, so in the stable state what happens, this flip-flop will be holds the transistor on. In the stable state, the transistor is at the on state. Okay, thus which clamping the external timing capacitor to ground. So because of that transistor is on, which will clamp the external capacitor to ground, that will which will connect the external capacitance to ground. Okay, the output remains ground at this particular potential. So when the capacitor is grounded, that is no charging capacitance, the discharging, the output will be low at this particular point. Okay, that is the thing. Now, as a triggering pulse is applied, so you can see here. So as a triggering pulse is passed through, that is 1/3 VCC, 1/3 of VCC is applied. That means we have a one transistor here and one transistor here. So first transistor will receive the 2/3 of VCC, second transistor will receive the 1/3 of VCC. So you can see here. So as the triggering passes from, wait a minute, they said, so as the triggering passes through VCC, 1/3 of VCC, so in this case what happens, the flip-flop what we are using, you just recall the circuits present in the IC555 timer. The flip-flop will resets, okay, then 0. The transistor initially it is in the on state, so now the transistor will be, and which will short circuit across the capacitor. So capacitor will be short circuit in that case. Because of this, the capacitor will be short circuited across this timing, capacitor is released. Okay, and then the Q means the flip-flop output is low, then the output of the your 555 timer goes to high. Okay, so this is the operation here. So initially what happens, initially transistor is in the on state. Okay, then the capacitor is grounded, so potential at this particular is 0. In the second case, the transistor is off, because transistor is off, why? Because 1/3 of VCC receives at the output side, so which makes the transistor to go to off state. So in that case, the capacitor releases, that means discharges. Okay, and then the output will be output of your flip-flop will be low. Once again, it will results in the higher output at the as multivibrator side. Okay, that is the operation. Next is This is your internal architecture of your stable multivibrator. So in the previous video we discussed about just a block diagram representation, and it is your internal architecture. You can see this part is your internal architecture of your stable multivibrator. As I said, it consisting of a comparator. It consisting of a comparator. This comparator compares 2/3 of VCC with the triggering voltage. This comparator will compares the 1/3 of VCC with the triggering pulse. Okay, so it is, as I said, it's a transistor, discharge transistor, as I said. So it is to reset one. So here, when the triggering pulse is given, so in the triggering, so you can see here, when the triggering output is given to the comparator, first comparator, that will compares the triggering pulse with the 1/3 of VCC. That is 1/3 of VCC is compares. So this output will be low at that point. The output of the comparator will be low. Okay, that makes the capacitor to, that is, there is no capacitance action. Okay, so when the positive pulse is applied, positive triggering pulse is applied, this is during a negative pulse is applied. So when the positive pulse is applied, okay, so then we'll have what happens. So you can here also positive pulse is applied. So then the 2/3 of VCC, the second comparator, this will compare 2/3 of VCC with the your triggering voltage, and that in that case that makes the this capacitor, then the current flows from this external resistance to the capacitor, and then the capacitor starts charging. So this is your capacitor charging. Okay, once again, if the flip-flop resets in the second cycle, then the comparator 1 compares the output voltage. This comparator will compares the output voltage 1/3 VCC with the triggering voltage. In that case, capacitor starts discharging. So in the same way, in every time the capacitor's charging and discharging will happens. So when the flip-flop will be off and when the transistors are acting, so capacitor starts charges, and then capacitor starts discharges, and capacitor charges discharges. Every time whenever you will get the capacitor charging, you will get the positive output. When the capacitor is discharging, you will get the negative output. Okay, so this is, so it is a charging and discharging, charging and discharging. So when the capacitor charges, it will get the positive. When it is discharging, you will get the negative. So here once again it is charging, you will get the positive. When it is discharging, you will get the negative. So this is how you will get the positive and negative waveforms, so during the charging and discharging of capacitors. So this is the equation, this is the triggering pulse which we are given. This is the voltage across the capacitor waveforms, and this is the output voltage of your comparator, your multivibrator, and it is when you reset, you will get this particular pulse. Okay, so this is about monostable multivibrator, right? Next we'll discuss about the behavioral aspects of monostable multivibrator, how this monostable multivibrator will be behaves. Okay, so this monostable multivibrator is constructed by adding the external capacitors, as I explained already, by external capacitors and resistance to your 555 timer. Existing 555 timer, there is a 555 timer we have, so we are connecting on external capacitance and resistance, okay, to have the monostable multivibrator. Okay, this circuit is a single pulse of desired duration when it receives the trigger signals, hence it is called as one shot or monostable. So it will produces the only single pulse of a desired duration. Desired duration, you know how the duration of the pulse will be depends upon the charging and discharging time of the capacitor. Okay, so as it is generating only single pulse for a desired duration, so when it receives the triggering signal, so it is called as a one shot type of multivibrator or monostable multivibrator. The time constant of this resistance and combination will determines, as I said, the time duration of the resistance of this capacitor will decides the length of the pulse, how much length the pulse should be, how much duration the pulse should have. It will decided by your resistance and capacitance, charging and discharging of capacitance. So uses of this monostable multivibrator, where it is used. So first one is, it is used to generate the pulses of correct height and duration for a digital system. So in various digital applications, it is used to generate the pulses, pulse durations, and also it is used to turn the circuits or the external components on or off for a specific length of time. That is once again to generate the specific pulses. And the next is can be cascaded to create the variety of sequential timing pulses. So if you connect the cascaded if you connect these multivibrator in a cascaded fast, we can get the sequential timing pulses. Okay, so these pulses can allow you to time sequence the number of various related operations, right? So this is about your multivibrator. So applications of this monostable multivibrator is it is used in a missing pulse detector. If any one pulse is missed in a sequence, it can use to detect the missing pulse. And linear ramp generator to generate the linear ramp signals. So once again, by varying the capacitance charging and discharging time, we can get the different varieties of waveforms here. Linear ramp generator, frequency divider, pulse width modulations, okay, and many more. Okay, they are the applications of your stable and monostable multivibrator system. Okay, this is about mono. What we discussed is monostable multivibrator. Today we discussed about monostable, why it is called as monostable. Only one stable state and other is a quasi stable state. That is if you observe the waveforms of this one, so there is one stable